Here we are, Algebra 1. In this section, we're going to be graphing from a chart. So we've already been discussing functions, and we can use an input-output chart to graph functions. Remember, the input values are going to be your domain values or your x values. Your output values are your range values or your y values. So our independent variable is x, it's going in. Our output y is coming out. So I've got a little chart ready for us to go here. Here's our function, y equals 2 times x minus 6. Remember, a function is nothing more than a set of instructions telling you what to do with your input. So when x is equal to -2, let's plug it in. 2 times -2 minus 6, that's -4 minus 6, that is -10. That creates the point, -2, -10, which we can now graph. Back 2, down 10. Let's plug in -1 and we'll start seeing a pattern. 2 times -1 minus 6, -2 minus 6, that's -8. That's -1, -8. So back 1, down 8. Let's plug in 0. 0 is always the easiest thing to plug in. So 2 times 0 minus 6. 0 minus 6 is -6. So when we plug in 0, that gives us a very important point. It's called the y-intercept. Any point that we plot on the y-axis is a y-intercept of the graph. In this case, it's 0, -6. So look at what's happening to our y values. They are increasing by 2. -10 plus 2 is 8. So I'm betting the next one's going to be -4. Let's check it out. 2 times 1 minus 6, that's 2 minus 6, that's -4. We are correct. Lastly, 2 times 2 minus 6, 4 minus 6, that's -2. So we've got 2 more points to plot, and then we can graph our function. So I did give you these input values, but this is going to be a continuous function because if y equals 2x minus 6, we are not limited to what we can plug in for x. So this will actually be a linear function. And notice the spelling of linear. L-I-N-E, line. A linear function makes a line. So 0, -6, 1, -4, and 2, -2. Hopefully this looks very familiar, like things that you have done in pre-algebra, where we have a line that has a slope of 2 and a y-intercept at -6. So there is our linear function. Let's see what's next. Because we can graph anything from an XY chart. It works every single time. It's not always the most efficient way to graph, but it definitely works every time. The next thing to remember is that f of x and y are interchangeable. They mean the same thing. Remember, f of x is just giving the function a name. This is the f function. So x and f of x is the same as x and y. So for this function, I left the x values wide open because we are definitely able to choose the members of our domain because there are no restrictions as to what I can plug in. So my function says take the absolute value of x and add 1. So let's plug in some numbers, maybe like, how about -4, -2, 0, 2, and 4. Just choosing even numbers this time. We can definitely do that. So what do we have? We have the absolute value of -4 plus 1. The absolute value of -4 is 4. 4 plus 1 is 5. Next, let x be -2. The absolute value of -2 is 2. 2 plus 1 is 3. Let's go 0. The absolute value of 0 is 0. 0 plus 1 is 1. Absolute value of 2 is 2. 2 plus 1 is 3. Notice how the numbers for our range are starting to increase. The absolute value of 4 is 4. 4 plus 1 is 5. Let's plot these points. Here they are. Negative 4, 5. Negative 2, 3. 0, 1. 2, 3. And 4, 5. Plot these points. Back 4, up 5. Back 2, up 3. Over 0, up 1. Over 2, up 3. Over 4, up 5. So this is an absolute value function. And in an absolute value function, we always have a hard angle here formed by these two rays that make up this particular graph. So there we go. We can always graph using an input-output table, and f of x and y essentially are interchangeable. Next, we've got a different type of function. This is called a quadratic function. Quadratic. How do I know that? Because my x is being raised to the second power. So once again, I've got a new function. This is the g function. So x and g of x. So y and g of x, same thing. I'm just giving the function the name g. And my function says to square first and then multiply by 1/2. Now, we need to choose our values for x wisely here. Because of order of operations, we have to square first. So would it make sense for me to plug in a number, say like 10? If I plug in 10, I square 10, I get 100. That's not helpful. So let's keep our numbers relatively small, and let's plug in some negatives as well. So how about let's go -3, -2, -1, 0, 1, and 2. This will give us good enough information to plot this function on the coordinate plane. So here goes. 1/2 of -3 squared. So -3 squared is 9, and half of 9 is 4.5. This is a good opportunity to utilize decimals because we're just dividing by 2 and we multiply by 1/2. Next, 1/2 times -2 squared. Remember, square first. -2 squared is 4. Half of 4 is 2. Plug in the 1. 1/2 of -1 squared. Square first. -1 squared is 1. Half of that is 0.5. The 0. 1/2 of 0 squared is still 0. And remember, this again will be our y-intercept. Next, 1/2 of 1 squared. 1 squared is 1. Half of that is 0.5. So we see these y values starting to repeat again. So 1/2 of 2 squared. 2 squared is 4. Half of that is 2. And we'll put one more down here just so you can see what's happening. Let x be 4. What happens if x is 4? 4 squared is 16. Half of 16 is 8. That gives me just one more point in the table to consider. So let's plot these points. So remember, these are all points. So -3, 4.5. Back 3, up 4.5. Back 2, up 2. Back 1, up 1/2. 0, 0 is our y-intercept as well as our x-intercept. 1.5 over 2 up 2, and then over 4 up 8. Now, I purposely chose 4, 8 because I want you to see what we're working with here. A quadratic function has a line of symmetry coming down the middle of it. So, if there is a point on the left, there's one that will mirror it on the right. We can see that there, also here. So let's plug in the one that is going to be just across when the y value is 4.5. So 1, 2, 3, 1, 2, 3. And then we can also do it from the right. 1, 2, 3, 4, 1, 2, 3, 4. And here, this is a parabola. A parabola is a nice, smooth curve. It's not pointy on the bottom like the absolute value. It's a smooth, continuous curve, and this bottommost point is called its vertex. So that's a quadratic function. Once again, an XY chart will help us graph anything. And we've got one last quick problem. A pool containing 20,000 gallons of water is being drained. So important information here, 20,000 gallons, and it is being drained. Next, every hour, the volume of the water in the pool decreases by 1,500 gallons. So every hour, the volume is going down by 1,500 gallons. A, write a function to represent the situation. So let's do A right down here. So what is my function going to be? Well, my pool is starting with 20,000 gallons, and it is losing 1,500 gallons every hour. So starting with 20,000, decreasing by 1,500 every hour. So let's write this as a function of volume. So volume in terms of H. This is the volume function. The volume in terms of hours equals 20,000 minus 1,500 H. That's letter A. Let's make a quick table of values, which is what letter B says, showing how the volume is decreasing over time. Making a table helps us understand and see exactly what's happening in the function. So let's bring that down just a little bit. So, and I'll just write it just like so. So let's see, after 0 hours of being drained, the pool still has 20,000 gallons. After 1 hour of being drained, 1,500 times 1 is 1,500. 20,000 minus 1,500 is 18,500. After 2 hours, it will be down another 1,500. So 18,500 minus 1,500 is, what is it? 17,000. Here we go. So let's think about this an easy way, and this is where the table of values is helpful. So we can see that after 2 hours it went down by 3,000 gallons. So how about instead of going down by 1, how about we go down in increments of 2? So after 10 hours, how much had left the pool? Well, after 10 hours, 1,500 times 10 is 15,000. So 20,000 minus 15,000 leaves 5,000. So after 10 hours, there was only 5,000 gallons left in the pool. So let's go down another 2 hours. After 12 hours, 3,000 more gallons were gone, 2,000 were left. Now, getting to here is going to help us answer letter C. How many hours until the pool is empty? Well, after 12 hours, there were only 2,000 gallons left. So that means 13 hours later, there were only 500 gallons remaining. So that would mean for letter C, approximately 13.5 hours later, the pool was empty. So the chart helps us to make a reasonable guess for letter C. Could we find it exactly? We could, but I just wanted you to see in this particular video how a chart is helpful in helping you understand what the given information in a problem.